This series of videos is a visual overview of parabolas. Rather than just go over the equations of the quadratic formula, I want to look at the graphs and how the coefficients in the quadratic formula affect the graphs of the parabola. If you haven't already, please take a second and subscribe to this channel. And thank you for watching. Let's begin now on MathCat. 3, 2, 1. Let's take a look at the graph of a parabola that has both an x squared term and an x term. First, we'll check our scale, zoom 6, z standard for the scale, and we'll enter our standard y equals x squared, just so we have a reference point. Y equals x squared is a parabola of average width with the vertex at the origin, and it's pointing upward. What happens if we introduce an x term? Y equals x squared plus 2x. The parabola shifts in two different directions. It shifts in the negative x direction and it shifts in the negative y direction. In fact, the vertex of this parabola, y equals x squared plus 2x, the vertex is at minus 1, minus 1. It's a little hard to see on the graph, but that vertex is minus 1, minus 1. What if we have y equals x squared minus 4x? Maybe this will make it clearer. Y equals x squared and then minus 4x. The vertex is shifted in two directions again. This time it's at plus 2, minus 4. So when we introduced a 2x term, the vertex was at minus 1, minus 1. When we changed the sign on the x term and made it minus 4x, we got a positive shift in the x direction and a negative shift in the y direction. The vertex is now at 2, minus 4. The parabola is still an average width. We haven't changed the size or shape of the parabola, and we haven't shifted the direction. Those things are controlled by the coordinate in front of the x squared term. But we do notice this double shift, and it's a little hard to see what's going on just from the graph. The generic formula for our parabolas is y equals ax squared plus bx plus c. And now we're looking at a parabola that has an x squared term and an x term, but no constant. So c equals 0 in the parabolas that we've been looking at in this video. When we said y equals x squared plus 2x, we found a shift in the vertex to minus 1, minus 1. The parabola was still average width and still facing upward, but the vertex had shifted to minus 1, minus 1. And then we looked at y equals x squared minus 4x. And the vertex shifted this time to positive 2, negative 4. It was still average width and facing upward. In order to figure out what's going on, we actually have to look at some equations for this one. It turns out the vertex of a parabola, we'll give it the letters h and k, where h is the x coordinate of the vertex and k is the y coordinate of the vertex. H equals minus b over 2a. The b and the a are coming from the quadratic formula. K, the y coordinate of the vertex, is a little more complicated. It's 4ac minus b squared over 4a. Again, the a, the b, and the c are coming from this form. Right now we're looking at parabolas where c equals 0. There's no constant term. Well, the h part of hk has no c in it anyway. So the c equals 0 doesn't affect the x part of the vertex. If both b and c were 0, you can see that h would be 0 because the numerator would be 0. So h equals 0. You'd have a vertex at somewhere along the y-axis because the x-coordinate would be 0. And if b and c were both 0, here you've got a 0 in this term and a 0 in this term, so your numerator would be 0 if both b and c were 0. So you're left with just y equals ax squared. You'd have your vertex always at the origin. But in this case, we're looking at just c equals 0. So c equals 0 doesn't affect our h equals minus b over 2a. So let's calculate that from our first equation that we looked at. Y equals 1 times x squared, so a is 1, and 2x, b is 2. So if a is 1 and b is 2, you'd have minus 2 over 2 times 1. Minus 2 over 2 is minus 1. You'd have your x-coordinate of your vertex at minus 1. That's how we got that. C is 0, so this term goes out. and we have minus b squared. B is 2, so minus b squared is minus 4 over 4 times 1, 4. Minus 4 over 4, minus 1. That's how our vertex ended up at minus 1 for this first equation. In our second equation, we had y equals x squared minus 4x. In this equation, b is minus 4. We have a minus 4 over 2 times 1, 2. Minus a minus 4 is a positive 4 over 2. That's where we get our 2 from. Positive 2. The y-coordinate of our vertex, k, c equals 0, so this term goes out, minus b squared. B is minus 4, so we have minus 4 squared over 4 times 1, 4. Okay, minus 4 squared is positive 16, but this is minus positive 16, so it's minus 16. Minus 16 divided by 4, minus 4. That's where we get this vertex, 2 minus 4. So when we introduce the middle term, bx, because the vertex formula is dependent on b in many ways, in more ways than just a and c, finding the vertex is more a matter of figuring out the answers to these equations. With just the a and just the c, a lot of these terms go out and we can just visually see what happens to the parabola. But when we introduce the middle term and there's a value for b, we actually have to plug in the values to find the vertex.